Hi everyone. Next question on continuous random variable. The continuous random variable x has PDF f of x, where f of x has been given in two parts. You're asked to find the value of the constant k, find probability of x lies between -1 and 1, and lastly, find probability of x is greater than 1. So let's solve this question. The first part is you need to find the value of k. So to find k, you need to use the result, integrate all values of x, f of x dx equals 1. So we have our function f of x, which has been divided into two parts. So we need to calculate two separate integrals. So we can see that the first part of the function lies between -2 and 0. So we integrate from -2 to 0 the function k x plus 2 to the square dx, plus we integrate from 0 to 1 and 1/3 the function kx dx. This equals 1. Now we integrate. We take the k outside the integration. -2, 0. We have x plus 2 to the square dx plus, now the 4k is a constant, so we can remove the 4k outside. What we have left is 1 dx equals 1. K we integrate, so x plus 2 power 2, so we add 1 to the power, so we have x plus 2 power 3. We divide by the new power and then we multiply by the derivative of the inside, which is 1. This is between limit -2, 0 plus 4k. We are integrating a constant, which is x. Again, 1 is the same as what? 1 times x power 0. So if we add 1 to 0, we have x power 1. This is between limit 1 and 1/3 equals 1. Next step is to replace the limits. So we can remove the 3 outside. So we have k over 3. We are left with x plus 2 to the cube between limit -2, 0 plus, we rewrite this. So let's put it 4 over 3 and then 0. K over 3, we take upper minus lower. So 0 plus 2, 2 power 3, 8 minus. -2 plus 2, 0. So we have 8 minus 0 plus 4k. Here we have 4 over 3 minus 0. This should give us 1. Simplifying, we have 8k over 3 plus 16k over 3. We have 24k over 3 equals 1. K equals 1 over 8. So we have the function f of x, k, which is 1 over 8. You multiply by x plus 2 to the square, valid for x lies between -2 and 0. Second part of the function, 4 times k, we have half, valid for x lies between 0 and 1, 1/3, and then last part 0 otherwise. The graphical representation of this function is given here. So as you can see, the first part of the function is from negative 2 to 0, and the second part of the function is from 0 to 4 over 3. The second part, you're asked to find the probability that x lies between negative 1 and 1. So we need to find the probability of from negative 1 to 1, which means that we need to find the probability of the shaded part here, the area of the shaded region. So this probability represents the shaded area here from negative 1 to 1. The first part of the function is valid from negative 2 to 0, and y is equal to half is valid from 0 to 4 over 3, which means that we need to calculate two separate integrals. We integrate the first function from negative 1 to 0, plus we integrate the second function from 0 to 1. So probability of x lies between negative 1 and 1 is going to be, we integrate from negative 1 to 0 the function 1 over 8 x plus 2 to the square dx, plus we integrate from 0 to 1. 0 to 1. So the upper limit of the first function becomes the lower limit of the second function, plus integrate 0, 1 half dx. So we are basically finding what? The probability from what? From negative 1 to 1. From lower limit minus 1 to upper limit 1. 1 over 8 integrate minus 1 to 0 x plus 2 to the square dx, plus half integrate from 0 to 1 1 dx equals 1 over 8 x plus 2 increase power by 1 divided by new power multiplied by derivative of the inside 1 between limit minus 1 0 plus half. We integrate a constant 1 becomes x 0 to 1. Next, we are going to replace the limits. So we have 1 over 24 x plus 2 power 3 between minus 1 0 plus 1 over 2. Now we replace the limits. So we have 1 over 24 0, so we have 8 minus 1 plus 2, we have 1 cube, which is 1, plus half 1 minus 0. We have 1 over 24, 8 minus 1, which is 7, plus 1 over 2 multiplied by 1, which is half. So we have 7 over 24 plus 1 over 2. We simplify, we get 19 over 24, or in decimal form 0.792 to 3 significant figures. Find probability of x greater than 1. From the graph, we need to find greater than 1. So we need to find what? This part, the shaded part here, which means that we have to only integrate the second function from 1 to 4 over 3. We have probability of x greater than 1 is equal to, we integrate from 1 to 4 over 3 half dx. So we take the half outside, 1 4 over 3, 1 dx, half, we integrate, we have x between 1, 4 over 3 equals half upper limit 4 over 3 minus 1. We simplify, we have half multiplied by 1/3. The probability is 1 over 6.